In this video, we're going to go over programmer-defined functions and review programmer-defined functions. All right, so here is a little bit of code. Here we have one programmer-defined function. The name of the function is calc remainder. This function has two formal parameters of type int, and it has a return type of int. So this is basically called an integer function. What's going to happen is this function is going to take in two integers. The two formal parameters are integers. When the function is called, then that's called arguments. So the two arguments to the function will be integers. This function is going to do a very simple calculation, and then it's going to return an integer. So what we're going to do is we're going to practice, and we're going to pretend like we are the computer, and we're going to, over here, this is a memory map. So we're going to run through this program, this very small program, and watch what's happening in memory, watch the local variables, and review how programmer-defined functions work. All right, so let's get started. Once your program compiles, it's going to start executing at the first instruction at the beginning of the main function. So the first instruction at the beginning of the main function is it's going to declare three variables. When you declare variables, technically what you're doing is you are allocating memory for those variables. So this is a memory map. This represents your RAM of your computer. So the first thing that's going to happen when this program executes is these three variables, first, second, and remainder, are going to be allocated memory. That's what happens when you declare a variable. So the way that we do this is we represent our memory like this as a table, and this represents your RAM, and your RAM has addresses, and it starts at address 0 and goes down from there. So I'm going to be talking about addresses as we can keep the 0 here. So this is address 0. And again, this is just a small snippet or representation of your RAM. And so when int first gets declared, your operating system is going to find an empty location in memory. Usually there's going to be a section in memory that belongs to your program. And it's going to give that address. So it's going to say, oh, okay, here's an empty location in memory. So this would be the address. And it's going to give that enough memory for an integer variable. So the integer variable is going to be located, say this address is address 1000, and every time you execute, this variable could be placed at a different address. So the actual address is not important, but the fact that the variable has an address and a location in memory is important. And in the C language, if you put an ampersand in front of the variable name, that turns it into an address. So the variable first is going to be located at this location in memory, and that's going to be the address of, and that's an ampersand. My ampersand is not, there we go, address of, and the variable's name first. So you can see that we're already using address of when we're using scanf right there. Scanf, the second parameter or argument to scanf, is actually the address of the variable. And then we're going to find memory for our second one, which is the name of the variable is called second. And then we're going to allocate memory for the third variable, and the name of that variable is called remainder. So I wanted to point out that depending on a lot of factors, it's not guaranteed that your variables are going to be in memory in order. So I purposely put them out of order. Now right here, I'm going to draw a line just to indicate for us to understand that these three variables, remainder, first, and second, those three variables are local to the main function. So the main function, and in memory, they might not be in the same section, but just as a visual, these variables are local to the main function. The main function has three variables. It has first, second, and remainder. It doesn't know anything about calc remainders variables. All right, and also that each one of these also has an address. So this is the address of remainder. And this is the address of second. Now, inside here would be the value, but because these variables don't have any values, we don't know what their values are. So we're going to have a question mark here until we get to the next statement. So we've finished the first statement. We've declared the variables. Now the next statement right here is going to print a message onto the screen. And then this statement right here is going to ask the user to give a value for the variable called first. So we're going to get a value for the variable called first and say the user is going to enter the number 11. All right, so the user enters the number 11. And then we're going to continue on to the next. So Scanf, what happens with Scanf, your computer is going to find the address of first and it's going to put the value there, which is 11. So the variable is first, the address is the location in memory starting from 0, and the value that is there is an 11. So those of you who are not paying very good attention, I'm going to repeat that this 11 was put in by the user. It was not assigned because we don't have any kind of assignment statement. So the value of 11 was entered by the user. All right, let's move on. Our next statement here is a printf to print onto the screen. And now we have another scanf in which we're going to have the user enter a value for the variable second. So our variable, oops, I had the question mark in the wrong spot. Our variable second is right here. This is the address of second. And now we're going to have the user enter a value for that, and we will enter the number 9. So we now have our first is 11 and our second is 9. All right, so now we are at this statement right here. So what happens on this statement right here? On this statement right here, we have a function call. So we're on this statement. We have a function call to the function called calc remainder. So what's going to happen now is our program is going to jump out of the main function and jump down here to the function call. So the first thing that's going to happen is the calc remainder function is going to get called. And then we have two arguments here. Our first argument is a variable called first, which has the value of 11. And the second argument is a variable called second, which has the value of 9. So when this function gets called, I'm going to pick a different color like red. This function is going to get called. 11 is going to get passed in here, and 9 is going to get passed in as for the second parameter, or the second argument. So when this function calc remainder gets called, this variable called int num, this is just like saying int num equals 11. So your operating system is going to find an empty location in memory. It's going to have this variable called num1. This num1 is going to have an address of num1, and num1 is going to have a value, and that value is going to be 11, is going to be assigned here. So the calc remainder function doesn't have any idea of a variable called first. The calc remainder function has its own variables called num1, num2, and result. So num2 is also going to get declared somewhere in memory. It's going to have an address. And so it's going to be assigned the value of 9. All right, so now the calc remainder function has been called. The two parameters have been declared and assigned the values. The values came from the function call. And now we're going to start to execute the instructions inside of this function. The first thing we're going to do is declare a variable called result. Result is going to get declared. It's going to have a location. And now just to point out, just like these are all local variables to the main function. These are all local variables to the calc remainder function. The calc remainder function doesn't know anything about a variable named first, a variable named second, or a variable named remainder. And the main function doesn't know anything about a variable named num1, num2, or result. Result will have an address. And result at this point does not have a value yet because we don't know what that value is. We go to the next statement. The next statement says you take num1 mod num2. So mod just means you divide num1 by num2. You decide how many times num2 goes into num1, and then the result is going to be the remainder. This is the modulus operator, which calculates the remainder. So num2 goes into num1 one time, right? 9 can only go into 11 one time. And when 9 goes into 11 one time, what is left over? The remainder is 2. So now we're going to go to the next statement right here, which is return result. Result has the value of 2. This whole function call right here is now going to have the value of 2. The return type is an integer. The result is an integer. So whatever gets returned from this function must match the return type. And so then this function right here. This is just like saying remainder equals 2. Now if we use different numbers, like if we used 11 and 8, the remainder would be 3. Then that would be like remainder equals 3. So that's this whole function call right here. This whole function call right here that takes in an 11 and takes in a 9. The result is a 2. So remainder is then going to be assigned the value of 2. So the other thing to remember is that these three variables, first, second, and remainder, are local to the main function. And these three variables, num1, num2, and result, are local to the calc remainder function. All right, so I'm going to pause for a second, and then I'm going to make a second video with some more information.